Good day, everyone. I'm Carlo Tan, who will continue to discuss the examples on how to solve the linear Diophanite equation, or what we call the LDE. Example number 1. Find the general solution of each LDE. We have A, 23x minus 50y is equal to 21. Letter B, 30x plus 47y is equal to negative 11. And number 2, determine all solutions in the positive integers of 18x plus 5y equals 48. So we have example 1a. Find the general solution of LDE 23x minus 50y equals 21. But first, what is the general solution? The general solution is that we have x is equal to c divides d times x sub 0 plus b divides d, and y is equal to c divides d times y sub 0 minus a divides d, such that t is a set of any integers. So we have here 21x minus 50y is equal to 21, such that a is equal to 23, b is equal to negative 50, and c is equal to 21. Existence of solution first, so we won't be confused. So we have d is equal to the GCD of 23 and negative 50, which is 1. And 1 divides 21. Therefore, the LDE has a solution. Using the Euclidean algorithm, we have 50 equals 23. 50 divides 23 is 46. So we have here is 2 plus remainder 4. Then 23 is equal to 4 times 5 remainder 3. And 4 equals 3 times 1 plus the remainder 1. So if our remainder is now our GCD, we have to stop. To make it easier, we substitute the divisor, and you'll see later why. Then let's copy 4 minus 3 times 1 is equal to 1 to solve for the general solution. So we have 1 is equal to 4 minus 3 times 1. Then 4 minus, let's substitute the 3, and we'll have 23 minus 4 times 5. Then substitute the negative sign, and we'll have 4 minus 23 plus 4 times 5. Then combine our 4. So we have 4 from the front, and we have here 4 times 5. And we'll come up to 4 times 6 minus 23. After that, we'll substitute the 4, and we'll have the quantity of 50 minus 23 times 2 times 6 minus 23. And we will proceed to 50 times 6 minus 23 times 12 minus 23. But wait, we still have another 23, so we combine. And then we'll have 50 times 6 minus 23 times 13. And from the given, 23x minus 50y is equal to 21. So we have to follow it. So it would be equal to 23 times negative 13 minus 50 times negative 6. So our x sub 0 is equal to negative 13, and y sub 0 is equal to negative 6. Thus, going back to the general solution, we have x is equal to c divides d times x sub 0 plus b divides d, and y is equal to c divides d times y sub 0 minus A divides D, such that T is a set of any integers. So we have x equals 21 over 1 times negative 13 plus negative 50t over 1. So we have x is equal to negative 273 minus 50t, and y is equal to 21 over 1 times negative 6 minus 23t over 1. So we have y is equal to negative 126 minus 23t. Therefore, our general solution is x is equal to negative 273 minus 50t, and y is equal to negative 126 minus 23t. Example 1b. So let's find the general solution of LDE 30x plus 47y is equal to negative 11. So we have a is equal to 30, b is equal to 47, and c is equal to negative 11. So we have d is equal to the GCD of AB, which is 30 and 47, and their GCD is 1, and 1 divides 11. Therefore, our LDE has a solution. So using the Euclidean algorithm, 47 equals 30 times 1 plus the remainder 17. Then we have 30 equals 17 times 1 plus our remainder 13. Next is 17 equals 13 times 1 plus the remainder 4. And we have 13 is equal to 4 times 3 plus our remainder 1. So since 1 is the remainder and our GCD is also 1, so we have to stop. Let's take note. So we have 17 equals 47 times 30 times 1. 13 equals 30 minus 17 times 1. 4 equals 17 minus 13 times 1. And 1 is equal to 13 minus 4 times 3. So we'll start at 1 equals 13 minus 4 times 3. So substitute our 4. So we have equals 13 minus 17 minus 13 times 1 times 3 equals 13 minus, so negative times 17, that would be minus 17, and we have 3 times 17, so we have 13 minus 17 times 3 plus the negative sign times the negative sign, that would be positive. Then we have 13 times 3. Next is we have 13 times 4 minus 17 times 3. Again, substitute the 13. So we have the quantity of 30 minus 17 times 1 times the quantity 4 minus 17 times 3. Then we'll have 30 times 4 minus 17 times 7. Again, substitute the number 17. And then we'll have 30 times 4 minus 47 minus 30 times 1 times the quantity 7. And then we'll have 30 times 4 minus 47 times 7 plus 30 times 7 is equal to 30 times 7. Then lastly, from our general solution, we have 30x plus 47y is equal to negative 11. Therefore, 30 times 11 minus 47 times 7. And we'll have x sub 0 is equal to 11 and y sub 0 is equal to negative 7. Thus, going back to the general solution, we have x is equal to c divides d times x sub 0 plus b divides d, and y is equal to c divides d times y sub 0 minus a divides d, such that t is a set of any integers. So we have x is equal to negative 11 over 1 times 11, which is our x sub 0, plus 47 over 1 times t. And that would be x is equal to negative 121 plus 47t. And we have y is equal to negative 11 over 1 times negative 7 minus 30 over 1 times t, which is y is equal to 77 minus 30t. Therefore, the general solution of LDE is x is equal to negative 121 plus 47t and y is equal to 77 minus 30t. Next example, we have number 2. Determine all solutions in the positive integers of 18x plus 5y equals 48. So we have a is equal to 18, b is equal to 5, and c is equal to 48. So we have d is equal to the GCD of AB, which is 18 and 5, and their GCD is 1, and 1 divides 48. Therefore, our LDE has a solution. So we have to use again the Euclidean algorithm. So we have 18 is equal to 5 times 3 plus the remainder 3. And we have 5 equals 3 times 1 plus 2. And we have 3 is equal to 2 times 1 plus 1. Next is we have to take note again. 18 minus 5 times 3 is equal to 3. 5 minus 3 times 1 is equal to 2. And 3 minus 2 times 1 is equal to 1. And then we'll have 1 equals 3 minus 2 times 1. Again, substitute the 2. So we have 3 minus, substitute 2. We have 2 is equal to 5 minus 3 times 1 equals 3 minus 5 plus 3 times 1. And then combine. So we have equals 3 times 2 plus 5. Again, substitute the 3. So we have equals the quantity of 18 minus 5 times 3 times the quantity 2 plus 5. Then equals, substitute 2. So we have 18 times 2 minus 5 times 6 plus 5. And then combine. So we have 18 times 2 minus 5 times 7. So from the given, 18x plus 5y equals 48. So we have 18 times 2 plus 5 times negative 7. So we have x sub 0 is equal to 2 and y sub 0 is equal to negative 7. Thus, going back to the general solution, we have x is equal to c divides d times x sub 0 plus b divides d, and y is equal to c divides d times y sub 0 minus a divides t, such that t is a set of any integers. So we have x is equal to 48 over 1 times 2 plus 5 over 1 times t. We have x is equal to 96 plus 5t. And we have y is equal to 48 over 1 times negative 7 minus 18 over 1 times t. And we have y is equal to negative 336 minus 18t. But wait, we have to determine all solutions in the positive integers of 18x plus 5y equals 48. So from the given, x is equal to 96 plus 5t and y is equal to negative 336 minus 18t, we have to know the positive integer solutions of x and y. So we have 96 plus 5t is greater than 0 and negative 336 minus 18t is greater than 0. So we have 5t is greater than negative 96 and 18t is less than negative 336. So we have t is greater than negative 96 over 5 or negative 19 and 1/5, and we have t is less than negative 56 over 3 or negative 18 and 2/3. So we have t is less than negative 18 and 2/3 but greater than negative 19 and 1/5. So let t is equal to negative 19. So let's find the x. So we have x is equal to 96 plus 5t. Then x equals 96 plus 5 times negative 19. X equals 96 minus 95. Therefore, we have x is equal to 1. And for the y is equal to negative 336 minus 18 times t. And we'll have negative 336 minus 18 times negative 19. So we have negative 336 plus 342. And we have y is equal to 6. Therefore, we have x is equal to 1 and y is equal to 6. So that x is equal to 1 and y is equal to 6 is a positive integers of 18x plus 5y equals 48. That's all. Thank you.